So thanks all for joining. You did start the recording, Nuno?
Yes, you can go ahead.
Okay, really good. Maybe since we have a nice group, we can do a quick round of introductions. I will start with myself, and then I'll hand over to Theo. Maybe everyone can also turn on their camera, then we all have a face with who we're talking to. I see people appearing on my screen. So I am Machiel Bijl. I'm the co-founder and CEO of Axini. Oh, someone can't unmute, no problem. And I'm here together with Theo. Theo is a specialist in well, everything that has to do with modeling, model checking, model-based testing. But maybe you want to add a couple of words. And there you are.
Yes, maybe we can say that we started on the right foot at the University of Twente both. So that's where we know each other from. But maybe you will say something about it in your lecture as well. And that we are currently implementing MBT, so the tool that you're going to get accustomed with today at various companies in the Netherlands, and I'm helping them there. That's it.
Shall I follow up with the order that I have on my screen? The first one I have here is Jan Peleska.
Hi, everybody. I'm a professor for computer science at the University of Bremen, specialized on safety critical systems verification and validation. In 1998, we have founded a spin-off company of the university, which is specialized on this area. And we have also built a model-based testing tool. And currently we are working on the next generation of these tools because we have the feeling that the commercial success is not as good as it could be for model-based testing tools. You are not selling that like sliced bread or something like that. And there are technical reasons for that. And so I'm not here to complain that our customers are too stupid to write decent models, but I'm here to think about the next generation of model-based testing tools that are really more customer friendly and can be used more easily. And perhaps you already have the perfect solution. Then I will bow my head at the end of the session.
Oh well, we're also open always to work together, so no problem. Then the next one is Arnab Shil, if I pronounce it correctly.
Yeah, it's okay. My name is Arnab. I'm doing engineering doctorate at TU Eindhoven. So I actually know a little bit about Axini, and I have some plans or some ideas about using MBT in a security based system, like for example, how to verify security or something. So some sort of like if I can use MBT in an exploratory way to identify if a certain security policy is good enough for ensuring the system is good enough for in some standard. So that's why I'm in this session, so that I can get some ideas about how to use Axini. Thanks.
Cool. And next to that is Gunaska.
Yeah, hello everyone. My name is Raghavendra Gunasekaran. So I'm a PhD candidate at Tilburg University. I'm working the topic of digital twins. So to be more specific, in the topic of digital twin dynamic consistency, which is about validating the runtime consistency of digital twins. Yeah, so I've been 2 years in my PhD now, and yeah, in my third year. Yeah, pretty excited to learn more about Axini today.
Welcome.
Thanks.
And let's see, next to that I have Karol Kobiela. Or are you the one that had trouble with the oh yeah, sorry, I can't unmute. No problem. I see you're from Verum company that does model checking and code generation, verified programs. Last time we also had some colleagues of you. And next to that, I have oh, where did everyone go now? I have Adam.
Hello, yep.
There you go.
I'm Adam Żurkowski. I work in the software research team in British Telecom's research department. I work in Joost Noppen's team. I gather you might know him.
Yeah, we do.
Yep.
Say hi to him.
Yeah, I think he wanted to join today, but he was pulled off on something else. But yeah, so I sort of dabble in a number of different areas, but around legacy systems migration and uplift and understanding is one of those areas, and the other one is quite a new strand of work we've started to dig into some of our software quality and software testing and things like that. So yeah, really interested to see what you've got here.
So let's start with the sharing of the screen. Thanks all. By the way, if you can keep your camera on, that would be nice. We also got that there's a feedback from people that when you have that, then for the online stuff, then it's easier to stay engaged. So that would help. Of course, it's not obligatory, but let's see if you see my presentation. Do you now see it in presentation mode?
Not yet.
Okay. Oh, yeah, I sometimes have that. Then I share it and then I present, and then I have to share it again because apparently it does not recognize that I want to have the better.
Yeah, that looks great. Thank you.
Okay, so it's an introduction to, well, it's 3 hours. On the one hand, it's it's quite some amount of time to play with it. On the other hand, it's like learning a new programming language. 3 hours is not enough. But the goal is not to have a whole commercial stuff, but just to have a hands-on session. So I will talk a little bit about Axini, what we do, what our philosophy is, and also a little bit about model-based testing. But we don't talk too much about where it comes from, what the theory behind it is. But if you are interested in that, just contact us. We also give, for example, courses at universities or in industry. Then we can also give a bit more about the background, or we could even do it as an MDENet session. But this is really focused on industry and practice and how to apply model-based testing. So we have, in order to connect, you need to have a username. And these are the ones that start from 40. So let's, for starters, give everyone a number. So Jan, if we give you 40, and then maybe I should add it in the chat, then then everyone remembers it. So
Shall I do that?
oh, that's good. Yeah, if you do that, then I can continue. Wait, where's now my presentation?
And it's MDENet underscore. So not space like it is now.
It should give well, you don't see the underscore because there's a line underneath. Do you see my presentation again now, or?
Yes.
Ah, cool. So we will give you a number. So it starts at 40 and then goes up. For the ones that were there last year, if you want to reuse your session, you can do so. But then you need to have remembered the number. And I think nobody did, but just in case, just let us know. And maybe it's good to check if you can reach this this course o2.axini.com, and then with the password is MDENet 2022. But if you cannot reach it, just let us know. And did you already hand out all the numbers, Theo, or shall I first continue?
I muted myself, but you can just continue and they will drop in as I make them. But they don't need them yet.
Yeah,
I
exactly.
think.
I think at the end of the first introductory part, we will have a short break in which you can check, and then we can help you out with the connection. There is a comeback session coming Monday from about 1 hour, because last time we did the same thing. Some people want to also do stuff at home, or want to complete stuff, or want to have feedback on how they did it. So that's what this session is for. So if you like to join there, let us know. So in that session, you can ask us all kinds of questions about the assignments. During this workshop, we try to handle all the questions in the main room. But if for some reason we need more time, there are breakout rooms. Normally, it's nice to handle the questions in the main room, because if you have a question, probably the person next to you also has the same questions. And there will be a questionnaire from MDENet. Nuno, will you send the questionnaire in the email, or do we need to share the link?
Yes, so basically I can put it in the chat now, and after here I can send it through email.
Okay.
Let me just put it in the chat here. Yeah, you go ahead and I'll share it in the chat in a second.
Yeah, no problem, no problem.
Here it is.
So a short word about Axini. So what we try to do is to help companies make software products that work when it matters. What Jan said in the introduction is actually a thing that I see with a lot of companies that are in the model-driven engineering area, that it's easy to tell what you do, but it's harder to explain to clients what they get when they buy it. So it's also what we saw a couple of years, and while working with clients, they actually said this is what we bring them, and it's also what we try to work for in our product. So to help deliver complex software products on time, but not only on time, but also without concessions on quality. And for that, we make a testing platform. That's the platform that you're going to use today. We have an approach around it, how to get it up and running within a company. For example, as here are some key clients like ProRail, the Dutch railways, Achmea, it's a big insurance company, and Thermo Fisher Scientific. They make all kinds of software hardware products, but for example, electron microscopes. And what we try to achieve is to avoid surprises, and especially to find issues during the development. What we see with many companies is that they do have a rigorous testing process, but a lot of the testing involves around an integrated product. So in an integration test, and especially if you have software hardware products, you see that during that phase, a lot of the relevant problems are found. But it's also late in the development process. So if you've, and quite often these integrated systems are ridiculously expensive. They're basically, your test benches are expensive, and there are not that many of them. So if you can, well, what nowadays is popularly called shift left. If you can shift left, you find issues earlier, which brings all kinds of benefits. And if after this you want to see how it works in your company, of course, no problem to contact us. And in a short time, we can show how it works and if it works for your products. Models. That's a highly overloaded term. In our case, models basically means state-based models. So under the hood, we use what's called symbolic transition systems. So those are transition systems with time and data. And here you see a picture that you are, well, in the end also going to or can make yourself, or something that looks pretty close to it. This is a solution for the smart door exercise. And here you see the smart door is an Internet of Things door. It starts in a closed state. You can open it, you can close it again, you can lock it, you can of course unlock it. And if you unlock it, try to unlock it with the wrong pin code too many times, it will shut off. But if you look inside the boxes, you see that the boxes are kind of a super state, or actually a sub process in our terms. And there you see again states and transitions. And so that's the material that we work with. And it's also a nice material because it gives the semantics to your modeling language.
So by the way, I don't see any change in the slides. Maybe
Yeah,
I'm the only
neither.
one. No, maybe I'm the only one.
So what do you see?
How to connect? We still get how to connect.
Oh,
Yeah, me too. Yeah.
oh,
So I think that the story was still followable. What at one point you said about boxes, and then I said, "Hey, I don't see any boxes."
let's see. Ah, good, but good that you're there. This was, of course, on purpose to see if were all paying attention. Uh,
I've added the names and the usernames for these passwords in the chat.
Window. It says. Oh no, no, it's probably possible to do it. Now you should see a state machine. Correct?
Yo.
Yeah. Ah, really
Yeah.
good. So this was what I mentioned. So this is this smart door assignment, an Internet of Things door that you are going to model in a bit. So you see there's a grouping concept to group behavior, or in a sub-process. So here you see a closed, say a closed superstate. Most people call it a superstate because UML has it as a concept. And then you have an open superstate, you have a locked superstate, and if you unlock it with the wrong pin code too many times, it will shut off. But if you look inside of the boxes, you see states and transitions. So there's a hierarchy of functionality. And this is also what we use under the hood. So we have a modeling language, but we translate it into these kinds of visualizations. If you have such a model, so the model is a description of the behavior of the system. And for many people, this is new. So it's not and because it's not a model like how you program. So it's not in a language like you have in a imperative language. But it's more a reactive. So you just describe if this happens, what can happen. Well, it can receive an open command, it can receive a closed command, and after that, other behavior is triggered. But if you have such a model, which basically is a specification of what your system, your implementation should do on its interfaces, then you can use that to generate test cases. And not only generate it, but you can basically execute, automate the entire testing process. So here in the middle, you see our platform. There's a machine reasoning component that reasons over the state machine and derives test cases from it and executes it against the system under test. And in order to reach the system under test, we need a thing called an adapter, which basically on the inside communicates in the terms and interfaces, also the technical interfaces of the system under test. And on the outside, it's standardized on the interface of the Axini platform. So suppose that this has a socket connection, then the inside will be some kind of a TCP adapter. If it's HTTP, it will be HTTP. If it's a database, it will be a database. And if you have those components together, you can automate the testing The platform looks up, what can I do? Oh, I can send an open command. I'll do it. What should then happen? Well, maybe something happens on another interface, or it sends a command back directly, and it will try to cover the state space according to certain test strategies, coverage criteria. So you can use the information that you collect during testing to do all kinds of smart next test cases. So you can look at it as a kind of you can compare it to a TomTom. And a TomTom, you can imagine that you create a TomTom by explicitly programming all the routes, the possible routes in a country. Well, even for a country as small as the Netherlands, that will be a humongous job. But in principle, you could do it. But of course, the TomTom does not work that way. It works based on a map. And if you have the map, then which is like the model in model-based testing, you can derive routes in whatever way you want it. And that's the same way with model-based testing. So the model is like the map, and we generate test cases from it. And it gives all kinds of opportunities to dynamically change test cases, to focus on good weather, bad weather, maybe on a specific change. And if the specification is updated, of course you have to update your model, but afterwards all your test cases are up to date again. So this is basically the trick that enables the power of model-based testing. And if you compare it to other approaches, so here we compare 3 approaches: testing by hand, manual testing, scripting like BDD kind of testing, and Axini kind of testing. And you see on the first in the black letters the steps that you need, the testing steps, and the green ones are potential extra steps. So if you do manual testing, of course you need a specification, you create your test case, you predict the outcome, you execute the test case, and you evaluate the outcome. And an advantage of this is that if you have a good domain specialist, you get pretty good test cases really fast. But of course, it scales, the scaling is limited. If you have script-based testing, like what is the column next to it, like BDD, of course, you still need a specification. But there's now an extra task, the programming, the scripting of the test, based on the test you created and the prediction of the outcome. And then you get the test automation for free, which is really nice because now you can, for example, start testing in a CI/CD environment. But what we see is if you have a complex system, and many of the systems nowadays have turned out to be pretty complex, but definitely in the world of hardware-software combinations, for a good coverage, you actually need a lot of test cases. And then you run again into a scalability problem and a maintainability problem, that you have so many test cases programmed that you have to update them after changes. And with model-based testing, or what we call model-based testing, the Axini model-based testing way, is you do need a model, but after that we automate the entire test process without the need for programming. So the test cases are created, the outcomes is predicted, and they're executed and evaluated. And some clients also use the model to generate parts of their specification. Or some of them actually use the entire model as a specification. So with that, you can, on the one hand, test a lot more, but you can also test things that are not possible with other test approaches. What I showed in this part, if you do manual testing, it's really hard for a system that has multiple interfaces to write a test script that also tests the system over multiple interfaces. And a technique like model-based testing is actually really strong. It's one of the areas where the modeling, but also the model checking actually originated from, to test over multiple interfaces. as you probably all know, there's the famous Boehm's law, which basically says, and at that time it was an eye opener, but the cost of bugs grows exponentially with time. I know that there are a lot of articles that says whether it's exponentially or not, and whether with agile it's better or worse than it was, but the fact remains: the earlier you find a bug, or even if you have ways to predict it, to prevent it, it saves time and money. And here I have it in a linear order, but nowadays, of course, it's quite often an agile, iterative manner. And what we try to do with the approach is to shift left, to find bugs earlier, so that in the integration phase we have we have less bugs. And of course, this is the ideal picture, that we have no bugs at all. But one of the things that you need to do for this is you somehow have to link or combine requirements and design with development. And one of well, there are basically two test approaches that do this, or two automated test approaches. Let's call it like that. There's the scripting, the test execution, test automation, and there's the model-driven test automation with model-based testing. But only BDD and MDD, they relate the requirements / design with the testing. And that's actually where part of the power comes from. So if you do that, then you can prevent a whole bunch of problems, because you and it's, well, for me it's an eye opener, but I see it's not for or eye opener, open door, but not for all clients. Basically, it says if you write down a more rigorous way of what the specification of the system is, then it prevents errors. And what you get is you get a shift left, because you already find problems during your, you find more problems during your requirements and design phase, and you find them immediately because you have an executable form in the development phase. And I have taken a couple of basically just two examples of why complex systems are so hard to test. And I know there are a lot more. I know that Jan Tretmans has a whole, I think he has 10 or 15. And last time I was in with the MDENet event, I think Jan Peleska also had a whole bunch of challenges. But well, one of them is the size, of course, but I'll abstract from that one. The one in the middle is variability, which is basically in data, and it's an exponential problem. So the variability in this example is the subway system with their sandwiches. And if you say, okay, you can have 10 sandwiches with 10 types of bread, 10 types of meat, and 10 types of vegetables, but we say for one sandwich we do one bread, 2 pieces of meat, 2 pieces of vegetables, then the number of potential sandwiches becomes 10 to the fifth, which is, well, ridiculously big to test. So the normal approach for testers would be to say, oh, we'll do it in a different way. We'll do it risk-based. We do equivalence partitioning. We do all these kind of things. But it's not like bugs know equivalence partitioning or boundary value analysis. In general, bugs live somewhere completely different. So to find all the bugs, you actually need a lot of test cases, and maybe not the 10 to the fifth, but a lot more than what we normally have. So this is a kind of problem that you, for example, see in insurance companies for pension-based systems or normal insurances. They have all kinds of conditions, or for example, the tax administration. Is your income in a certain category? Are you a man? Are you a woman? Do you have children? Are you married? Well, all these kind of things all become variabilities. And the other one, the one there to the right, is the connectivity problem. because it's basically the same kind of problem as variability, but then in connectivity. That is, if you have systems that communicate over several interfaces, then you have the same kind of problem. All these messages can come concurrently. So again, it's in this case, we have 4 other systems that the system can communicate with. So you get 10 to the 4th number of interactions. And this is basically a blow up that's hard to manage, but where model-based testing really shines to help. And if you don't do something to tackle this problem, and this is the thing that we see a lot of in practice, is that you find the problems basically after development, so during integration time. And well, this is the part, if you talk about shift left, basically nowadays, if you find bugs in your integration of acceptance, well, then I wouldn't say you're too late, but then you get bugs from integration into your new development sprint. So you can develop less than you actually wanted to, and then you run into, yeah, you basically run more and more behind. We see a lot of companies that already try to use BDD, but you see, we also sometimes see companies use BDD that basically have a system that has one of these challenges that we mentioned. And what we then see is that the BDD is not enough. So there is what we see a gradual move from BDD towards MDD. So where modeling starts to really pay off. Basically, with the BDD, you have examples where you say, okay, I have a number of examples, and that's good enough. But if your complexity grows and the number of releases that you want to have grows, then at a certain times BDD will not be enough, and that's the area where modeling and model-based testing can start to help. What we normally see in high tech is this interface aspect, because quite often it's component based and there are many communicating components. So examples are interface modeling, complex business logic, systems modeling, and examples here are Thermo Fisher Scientific, ProRail, and ETAP. ETAP may create self-scanning checkout systems. And some examples that we do in the finance area, insurance companies, but also things that were a surprise for us. For example, client communication. A couple of years ago, I was not aware that that was a problem. But even there, with model-based testing, you can find bugs, and you can even make really nice models that non-technical people can understand. So then you get a model of a letter. So you can have a lot of different models. So this was a quick overview of what we do or what we can do. Any questions so far? Let me go back to the screen that I can also see you. I don't hear anything, so I think that's a good thing, right? I see now people nodding and smiling, so you do hear me. Then I think it's good to check if you can connect to the Course 02 system.
We cannot. So there's something wrong.
You cannot?
So,
oh.
No, not with those things that you provided. But maybe you can show the slide again. Maybe I did the password wrong.
Let me check. Let me remove this underscore because that's annoying.
It's good to see that we have Joost in the house as well now.
Hey, Joost.
He's muted himself. He's drinking coffee somewhere. Or a beer. So I remember him.
Let me share this again.
Yeah, that's the one that I copied also to the chat room. But
Let me see what I can do. Oh, wait, I should not have this one. Let's log out.
Well, my account is locked currently.
they all are. So whatever number you do, it will not work. What I can do is make the passwords fit. Machiel?
Sorry, that you?
I can reset the passwords to the passwords that we have gotten. That you have gotten.
Yeah, I think that makes sense, because else, let me see if I can, I have the same problem.
But it takes some time because we have a lot of users. Changes, save.
Weird, because I checked it yesterday, so now I wonder what happened.
Could you perhaps first get on with the conceptual presentation, and then we could make a break and you fiddle around with the system so that we might
Yeah,
log
I think
in.
that's a good one. And Theo, I make you in charge of the mess I made.
I'm the help, yeah, I know.
So then I'll continue with the because we start, so there are basically two courses on the menu. One is a coffee machine to start with, the infamous coffee machine that I once was a student of Jan Tretmans, and then you're obliged to have a coffee machine as an example. But the next one is the Internet of Things smart door. Let's see let's stop sharing and let's start sharing again. So do you now see the start sheet?
Yeah, that's okay, but you are still not in screen sharing mode, but in presentation mode. But I think you just go on like that. It's okay. It's easy to see.
Okay, but then you don't see what I see, so that's annoying. Wait, my apologies for that. I don't think I should change the
Sometimes it helps to first enter presentation mode and then share the application.
Yeah, that's what I just did. But
Oh, that's what you did. Sorry.
but I think I did it the wrong way. So maybe I. Yeah, this looks better. I think now you see the presentation mode, right, Jan?
Perfect. Thank you.
So there we go. So there are a couple of things that you will need. One of the things is the concept from the modeling language. Some background on that. It's a process and a data language. Well, for those of you who have dealt with languages before, so it's a process language inspired by Promula, but also by languages like Lotus, the process algebras from the 80s. It's by no way a process algebra, but it's if you are familiar with those kind of things, you will see the similarities. The model consists of a number of parallel processes. In our case, since this is a workshop of a couple of hours, we only have one process to keep it simple. But if you have communication, it will be via handshake channels. And there are two types of communication. There is external communication. So also in our case, the external communication is the interface via which you communicate with the system under test. But you can also have internal communication between processes. Models can become pretty big. One of the largest models is about 10,000 lines of code. So this is also a part where we worked pretty hard on to support big state spaces. For the behavioral part, you have a distinction between inputs and outputs. Inputs we call stimuli and outputs we call responses. There's a choice concept, which is non-deterministic. So for people that are new to that, that can be surprising in the sense that you basically say, these are the 5 things that can happen, but there's not a way to say, I want this specific choice to happen, not in the generated test case, but also not in the model. So it's really a declarative behavioral expression. There's a repeat statement, which is also non-deterministic, and there are for this assignment there are states and go to. You can also do it in a nicer way, but it takes more time to explain. There's the data part. There we took inspiration from Ruby, so it's Ruby-like. It's strictly typed, but strictly typed. And the data is used in 2 parts. So one can be the on the messages, so the actions. So it can be that an action has a parameter, what we call a label parameter. But of course, you can also just have data in your variables in that sense in your model, in your process. And for those of you that see that know Ruby, the modeling language, the Axini modeling language, is also an Ruby domain-specific language. So you can, that gives you the power of a preprocessor that quite often is handy, but not for the assignment today. And basically the part on the left, the behavioral part, is the only part that you will need. So the other part you don't. And from this language, we map that on symbolic label transition systems. To give some examples, so suppose that this is your, in this case, T machine. So you press a button and you get a T, and the dots in between are states. So you go from S0, which is the start state. If you press a button, so the question mark is an input, you go to state 1, and then it should output T. If you would like to model that, it becomes something like this. And we added on purpose also the boilerplate that you need, well, that all models need. You need to declare what your external interface is. Everything happens within a process that also needs some declaration, like what is the interface. But the entire behavioral part, what you also see here, are these two lines where you say, I receive this, the specification of the system says, after I receive a button press, then I send T, the system sends T to the output over the external channel. And for today, the things like timeouts you can ignore. Well, you cannot ignore because the model needs to have a timeout, but we're not going to do anything with time testing. And this is basically what I all said. Suppose now that you have a specification that says, or a system, after a button press, I don't care if I get coffee or tea. And of course, in this example, it's a bit a contrived example, but you could have systems where you say, I either get something and successfully or unsuccessfully, like I can get a coffee or I can get an out of water error. Those are the kind of examples that you can model in this way. It's a similar kind of construction. Again, you have the boilerplate for the external channel, the process. But in this case, the behavioral part says, okay, after I receive a button press, then I have a non-deterministic choice. Either the system sends tea or the system sends coffee. And that then results in such a system. And once you are logged into the system, you can also play a bit with how the visualization of the system, what it looks like.
May I just ask a question
Sure.
here?
Yeah.
I find that very interesting, and to my mind, it's very appealing to make that Ruby-based syntax. But with our customers, we had the experience that they are extremely hesitant in learning a new modeling language. They program in C++ or in C or something like that, and they are very hesitant in learning a new syntax. This is actually how we started our product in 1998, I think. We took the CSP process algebra syntax, which I personally find quite elegant, but our customers absolutely hated us for that. So we've changed that completely so that we have syntactic features that look more like C++ or so. Do you have the impression that your customers accept that, to learn such a new syntax? Is that okay with them?
Well, I think the answer is it depends. It is a hurdle for them to learn a new language. Actually, the Ruby part, quite often we heard that they like it because it gives more power.
Yeah.
But I don't know, Theo, you are more. Yeah, maybe you can say more about it.
Yes, it depends on the person. So we typically give courses to architects, so system architects, to developers, and to test engineers. And the architects don't care because it's just syntax. The good developers also don't care. They say, okay, I can get used to this, and maybe it's now annoying that I'm doing this training, but in a few weeks I understand it. And we also see it when they're using it. The not so good developers complain, and the test engineers complain a lot. But they already think in test cases, and we cannot model test cases. Yeah, we can model them, of course, but we don't like that because we want the tool to generate them. So yeah, they are hesitant, but if we force them to use it because we offer them a very good and nice tool, and they want to have a very good testing of their system, and then they have to use it, and then they get used to it, and there are other things that are harder to understand than the syntax, I think.
Yeah. Okay. Interesting, your experience. Okay.
Yeah, and we to add to that, indeed, the last part what Theo says, the ones that after a while really understand the power of modeling, those are the most proficient ones. They are the ones that say, okay, as long as I get a behavioral description, then I'm happy. But it's also one of the areas that we're looking into. How can we improve this modeling language? Can make it easier, lower level or a lower barrier. Yeah, it's not.
Yeah, it's one of the challenges, and I agree with your experience. Of course, the talented developers they are quite quick in picking this up, but others complain a lot.
Yeah.
Yeah, that's one of the problems. You have to write a model. You need some syntax for that. And if people are not willing to learn a modeling language, then they can't have success with model-based testing, of course. Okay.
I guess to a degree, it's a problem you have with, well, in the discipline in general, right? Because if it's not a model, then
Yes.
it's your next web framework, or it's your Django 2.0 or something like that. So in slipstreaming in, then I guess when you sell it, perhaps Terry, you can also give some indication of that. It's about the trade-off that you offer, right? I mean, people might be willing to go through the pain if they can see what gets promised on the other end, when they can see the benefit. I would imagine that might also be the reason why test engineers don't like it, because they don't really get the payoff, whereas architects and good software developers can say, well, if I do that, then I invest this much time, but in the end I get that much back. Is that the discussion that you need to have?
It's a trade-off. So what we now see is that there are certain companies that only do unit testing and MBT. So this MBT replaces something that they did before. Before they had to devise their tests in BDD-like frameworks. So they wrote their test cases, and the developers had to do that. If we look at the test engineers, they are just saying, okay, we have these requirements and this is the test plan, and I want to press these buttons and I want those to see those lights. So they think in test cases, but they don't write them. So if they write something, they are script copiers. So they have a Python script that they have seen before. They can reuse it for a new test case, and that's the level that they get.
Yeah.
But if I look at the developers, what we see is that certain developers say, okay, we are going to embrace MBT. We are only doing unit testing, and we get someone who to be an expert in this tool, and he will write a model as a blueprint of the SUT. And he has the pain of the syntax, but there are other things, as said before, that are harder. So the non-deterministic things that they encounter, the internal synchronization that's between the processes, for them that's much harder than the syntax. So the syntax is just a hurdle for the first 2 or 3 days.
Okay.
Okay, then I'll continue. Let's see. This is, yeah, so that's just what I already said. So the declaration part stays the same, so only the behavioral part changed. Another concept that you're going to use are states and goto. So here you have a machine that if you kick it too hard, then it will deadlock. So you can, if you nicely press the button and then the T, you can get a number of T's. But if you kick it, then it will deadlock. Same kind of concept. You again have the boilerplate, but the one way you can model this is that you say, I have a state loop, and I can either receive a kick and then don't do anything, basically no behavior afterwards, or I receive a button, I send a T, and I go to the loop state, and then I can do the whole thing again. Here you see a couple of new things. So here you see the semicolon can be used as a delimiter of statements. You can also do them on a new line, then you don't need it. And of course, you see the named states. And to go back to named states, you can use the goto statement. So in AML, gotos are not seen as evil, although for bigger models, quite often we have another concept, this sub-process concept that I showed you in the beginning. But sometimes in a specification, you literally have a named state in the specification, and it's really nice to also in the model use the same convention. Yeah, and this is a convention to keep your models nice and readable, that you indent after the state. And then there's another way to do that. So here you saw that in the previous one we had a loop for the for the looping back, but you can also do that without the go-tos and via the repeat statement. So here you have the same thing. Again, the kick goes to a deadlock, but here it says, well, I keep repeating these non-deterministic choices until I get a stop repetition. So here it says either I receive a kick and then I stop this repetition, and after this there's no behavior anymore, so I basically deadlock, or I receive the button, I send the T, and then AML automatically makes this into a loop, but without a named state. So this will then just be an internal state. So there is the AML quick reference card that some of you already got, but for the others, I will upload it in the chat. It's really handy to have it with you during the assignments. There's a whole lot of information on it, and a lot of it you don't need. So, and in our case, you only need this part: the choice, the repeats, the state, the go-to, the stop repetition, and the next repetition. But I know I've given this workshop a couple of times. I know that some of you really like to experiment, so go ahead. No problem to experiment with the other commands, or if you are curious how to do it, just ask. You should not be able to break the system, but for the coffee machine, and actually also for the for most of the Internet of Things door, you only need the ones that are circled. So the coffee machine is a bit a quirky assignment, in the sense that it is the main goal is to get used to the AML modeling language. So for that, we have a system under test. You cannot see it; it just runs on the same server as AML. We have already provided the adapter to you. We have hooked it up to the Axini modeling language or Axini modeling platform, and you just have to make a model and you can start testing. And you only see the results of the system under test via the executed test cases. So the goal is to make a model of the system under test. And what's important is that the direction of the messages in the model, so all the models that we use, is from the point of view of the system under test. And the reason for that is that we want our models to be a design artifact. So it should read as a specification of the system under test. And it is a beverage machine. So next to coffee, it also gives tea. It also gives lemonade. And we already set you up with a model that already does something, namely the coffee part, and you have to add the tea and the lemonade part. And some of these things will work different than you expect. And the goal of today is that for the things that don't work as you expect, to try to find out and to model the behavior of the system under test so that the test cases pass. So it's a bit different than what you would normally do, because then you would just model, and then if you encounter a deviation from your spec, you would say, hey, I found a bug, and you work together with someone else, a developer, to see what's wrong. And in this case, we just take the system as a given, and we try to make the model behave as the system under test does. So you have either you already have received it by mail, or else I will upload it in a bit. The laboratory, and you have later on for the smart door, you also get a specification. And the laboratory has both in it, the coffee machine and the smart door. So, but for starters, only focus on the coffee machine. So this is the discussion. Now I go to the, there we go. Let me take one of the I'll take a high number, and then I. So this is, shall I make it a bit bigger? I don't know how readable it is.
Yeah, now it's fine.
So here you see the, after you log in, did someone already succeed in logging in?
Yes, but I only see the smartdoor.aml.
I can also
Yeah,
see the coffee
so do I.
machine one.
Yeah, so
No, I can only see this smart.
if you go to the left to here to the, then you see, well, in this case I see a lot of them, but you should here see the projects, and you should only see 2, coffee machine and smart door.
Unfortunately, I only see smart door. Can somebody help me of the some of the other students?
Wait, let me check. Users, what number do you have?
41. Yes, that's me, 41.
You have smart door, and you have, you should have coffee machine. Yeah.
So there's a drop-down list, and from this drop-down list where you now have in the left, you have a smart door. You can also press coffee machine there. So what Machiel's now doing there in that neighborhood somewhere, there's written smart door, and then your number, and then you have to drop down it to the coffee machine.
And else we come back to that later on, Jan. Then we you can share your screen, and then we can see what you see.
Yeah.
But here indeed are projects. Well, I see a lot of them because I have administrator rights, and so you see more people that use this course. And then on the right side, you you can select test sets, and in this case, there's only one, a coffee machine. On the left-hand side, you see all kinds of things you can do with the system, and maybe you see some of the fewer things, but the important thing is the model itself. So this is the model that you get for free at the starting point. If you have a big screen, people like to toggle the visualization. Then you can see visualization on the left of it. There's a legenda that you can turn on and off, and there's a map that you can, mini map that you can turn on. So here you see the stuff that you already get is pressing the button coffee, and then the system should respond with a coffee. You can also press the visualization button itself, then you get it in a separate tab, especially with bigger models. That's nice. You can start testing. So you press start. So, and here's the stuff that I mentioned. You get, you already get the connection to the system under test. We already provided that for you so that you don't have to do that yourself. It is configured to run 5 test cases of 20 steps. And here you see one test case. I now selected one test case. That's, well, since the model cannot do very much, it keeps on pressing button coffee and getting a coffee. So you get 20 test steps with that. But they will become more elaborate, of course, after you did that. There's stuff that you can do here. You can visualize a test case. So if you like that to see where did the test case end up, you see the stuff that's covered. Well, in this case, everything is covered, of course, but especially if you have a failing test case, here you see a green part that marks the state where it ended, but in a failing test case, it will make that red. So then you know where in the model there was a potential problem. there's more stuff that you can do. There's a history of your test cases. You can also add all kinds of stuff to it, like you can add tags and but well, you don't, or descriptions and tags. You don't need that today, but if you want to play with it, that's fine. So here you can also add tags so that you can. The idea is that you can find your the interesting test cases easier. There's more stuff that you can do, but that you don't need. You can have configuration of test cases. You can have do all kinds of things with adapters. You can also explore the model. So in this case, it starts in the start state, and then it will tell you what is possible to do. So in this case, it can send a button coffee over the interface that's called controller. You can change things with timestamps. You've seen some information here between what states. I can press advance, and then at the oh, did I click the wrong stuff? Apparently. Then here you see the button coffee appearing just as a test case generation would do, and so you can build your own step through the model. See, and then you don't really need it yet, but you can also find some data about the if you use data in your model, what the valuation is. So in this case, you have a clock and you have a last external time. You have here some state vectors. In this case, it's only one, but those can be handy to debug. On the right, there's some information that you could use, like a help, a modeling tutorial, effective AML. There's this, and that's, I think, ooh, Theo, did I forget something?
Didn't you say that the tests should fail because the model is incomplete? Now you just showed 5 tests that passed with the current model, right?
Mm-hmm. Yeah,
and
yeah.
And how can we explore how to extend the model if so we need more tests that failed, don't we?
Not necessarily. So apparently the part that's now given, and it's on purpose, of course, to get you up and running in a nice way, a friendly way, is
Yeah.
the sub set of the functionality of the coffee machine that already works.
Okay.
So it is indeed a machine where you can press a button or you can send a
Yeah.
signal, coffee, and it gives you a coffee back.
So we can extend this
Exactly. Yeah.
the model now by other states for tea and so on.
Yeah, correct.
And then we can rerun the tests and they will see that the model has been extended. Is that right?
Yeah, that's correct. Yeah.
Okay.
Yeah.
Just give me 5 minutes to break your machine.
Yeah, that's the spirit. And I see you already found the coffee machine. That's great. And I will add some of the, where do I have it? For the ones that don't have it. How do I do that? I can add a file. Am I not allowed to share a file? Let's see what happens if I just do it like that. No, apparently I'm not allowed to. So I'll send it. Who are the ones that didn't receive an email yet? I know that you are one, Jan. Or maybe if the ones that don't have it received, if you add your email address to the chat, then I'll send you the information. So that's one. All the others already had it in the email. Okay, good. I see test cases being run. That's good. And Joost, did you already finish all of them, or you were not there the last time, on the second day, right? Yeah.
I wasn't there the last time during the second day. Today I'm a bit constrained for time as well. I already missed the first half an hour and I have to leave in about 40 minutes. So I'm kind of leaning on Adam a little bit, a bit of the work, to be honest.
But then I think I'll have to visit you in the UK.
You definitely have to drop by, and we definitely need to show you around here. You will be happy to know that I've been emailing Theo a bit on the background because I've been poking about on your platform a little bit, and I may have strayed into an area where I shouldn't have been. So there is that.
What, you already broke it?
I don't think I broke it not broken it per se. But...
No, but he came to a page that we should not be very proud of. That needs some attention from us as well.
Oh, so thanks for that, Joost.
I'm just beta testing your platform, Machiel. You'll be very happy to know that my hourly rate is very reasonable.
No problem.
Okay, but Joost, you should admit that the colors are not nice, but they are quite in your face.
It is very carnivalesque. I'll admit that.
Yeah. Okay, but it's not carnival in Eindhoven, so
there you go.
Well, not anymore, right?
Oh, not anymore. I don't know.
It's As Woensdag. Even in Oldenzaal, they don't carnival anymore. But
no,
in the morning you still could, right?
No, that is well. You don't do carnival, but what you do now is you, as we would call it, you would drown your sorrow. So you would go into the pub to be sad about the fact you no longer can go to the pub. Any excuse.
How I can add multiple receive buttons?
Sorry, how you can receive buttons?
Yeah, I'm trying to play around with the model, and there's the state called start, and I'm just trying to go to the T state, but the state start only receives one button, and I cannot duplicate the state start.
Ah, okay, yeah.
Can we wrap that into a choice statement with several receives, or how do you put several receives as an alternative?
Yeah, the choice is one option. You can also so for the start, you need to have a choice. So you have to say, I either receive a button for coffee or I receive a button for the tea. Yeah. But of course, what you do afterwards is different for the two.
Maybe you could share the slides, Machiel, as well, because then they can see what you have shown, and there are the choices also there.
I have a syntax bug with a go to or somewhere, so a slide would help.
Let's go there. For the go-to, states and go-to.
And receive and go to.
So here I have an, let's share the screen. Here I have an example of this, also with the named states, a loop where you say,
we can't see the screen.
You cannot?
Nope.
No.
Better?
No, something happens.
Oh, okay, choice.
Ah, that's the problem. So statement.
So it's like indentation sensitive?
No, the indentation doesn't matter. It's, well, it's only sensitive for yourself, but it is sensitive to curly braces, for example.
I just found that out.
And this one is an O from option. So it's sensitive if you make it a 0, what sometimes happens when you start modeling. And of course, if you don't separate statements either with a new line or a semicolon, that it also doesn't like that.
Yeah. Okay, that worked. Thank you.
Cool.
Everything passes. Okay.
Does it make sense to keep it on the page? Because then I'll you have a bit of a sneak peek.
Maybe you can share them in the somewhere.
Yeah, I'm not allowed to add things to the chat. So, or is it somewhere else that I can? I know with. I don't know why. Maybe it depends on whether or not you're allowed to. Because
yeah, works great.
yeah, you get tea and coffee.
Yes, of course.
Oh, then that's all you need.
I'm just surprised how nicely it shows you the error in the code. So.
What is the part that you like about it? You get a good feedback, you mean?
Yeah, the feedback is really nice.
Yeah, I know that some colleagues are now working on also doing stuff with language server protocols and jump to definition and all that kind of nice things to make it even nicer.
Yeah, I can see that there is some kind of linter running in the background.
Yeah.
I take it in the configuration where you specify the number of test cases that you want to run, that's essentially constraining the search or generation problem, right? So I guess is it for the person that's actually defining the model to actually also have an intuition of how many test cases should be run? Because I saw in the config you can change that as well, right?
Mm-hmm. Yeah, then it depends a bit on what you want to do with the with the test case. So suppose you just have a smoke test where you say, well, I want to have it finished in a really short time. Then you probably make that a short number, but maybe also with a different test strategy where you say, well, just cover all the states instead of cover all the paths. But indeed, it's what you would optimally do is just give it a goal and say, hey, this is your goal, and how many number of test cases do I then have? Well, we don't have that yet. That's the next version. But so the next best thing is to indeed have a bit of heuristic with the knowledge of how it pans out on your specific system under test, and constrain that with the number of test cases. Yeah.
Yeah, because I guess if you're actually executing this against a real system, well, a complicated system, that's not computationally cheap either, right?
Mm-hmm.
Yeah.
Yeah, quite often that's not the biggest. So the biggest problem is quite often the um, let's say that you want to achieve certain coverage on it. So and of course that depends on how much time you give it. I mean, theoretically it can cover everything, but it will also practically need a lot of time. So you have to find an optimum somewhere. And what we see is quite often clients go from, say, 100 test cases that they run to now to several thousands or 100,000s. But it's never enough. They always want more. But there is an optimum, of course.
Cool. Thanks.
Can you look at our?
We don't have clients at the 10,000 test cases. I think only maybe in the financial world, but not in the technical, because it takes too long.
Yeah,
they could.
Yeah.
And what we've seen, if there are errors in the SUD, we only need a few test cases to show it. So our experience that there are many paths to an error.
That's interesting.
Can you look at our models? Because now I have a problem that I don't understand. Or is that not possible?
Yeah. Shall we? Maybe it's a good one to do it. Do a thing in the group that maybe we take your model and take it as an example.
Oh, you can see, yeah, where I have done something wrong. Let me see whether I can share that. I think here we are. Can you see that?
Yeah.
Yeah, I've done the same thing with the lemonade, so I had the same problem.
I added the milk stimulus and a response, so that it's just a copy and paste exercise.
Mm-hmm.
And then I've added the milk state that returns milk, and handled the receive button. And then I'm getting errors here.
Yeah, and if you click on it, on a test case. So there it says at the top, it says the adapter does not.
The adapter doesn't handle the milk thing. This is of course plausible. It handles lemonade, right?
Yeah, exactly. Yeah.
Okay.
So here you see a bit of the magic that happens between model and system under test, because of course you need they need to understand the actions that they can do. So if you in the model, in this case, you used an action that the adapter does not know, then it's you don't want to have some kind of a weird technical error. Yeah,
I understand
that's what happens. Yeah. Yeah, that looks pretty good. So let's see. No more errors, only failed test cases. Aha.
What's the problem here?
Why it's failing? Yeah.
Expected responses. How do I read this trace? Oh, of course. It starts with pressing T, then getting T. Okay, coffee, coffee. So that looks like a copy and paste error here. The coffee in line 7 made the
So
test fail.
what you see is the system under test gave you a coffee back after the button laminate.
Oh, I see.
So that's
Yeah.
what it says. So that's the actual test case that was executed.
Ah,
And the one in red says but the model, that's what you see
expected
below,
laminate. So that way, yeah,
so you
yeah,
modeled laminate.
yeah.
But
And so if
apparently
I want here, that was coffee what the system actually gave back, right?
Yeah, exactly. Yeah.
So I'm adapting the test cases to the erroneous system under test. Very good. That's the way to do it.
One thing where it's being described that after asking for the lemonade, I should receive the coffee.
It does not. So so if you read the so basically what Jan just found was that apparently the system does not behave as you would expect
Yes.
based on the specification.
Okay, true. That's the problem.
But apparently it still does not.
No, right. Still lemonade.
So it's
is the system under test? Is it non-deterministic? Because now for lemonade it returns lemonade, right?
I think it depends on which actions you took before you pressed the lemonade button. Because in the previous one you pressed another button. I think there was T first.
No, I don't. Yes, right. You are.
And here you didn't press the T button first, so it might not be so much be non-deterministic as in we're in a different state of the system. Yeah.
Yes. Oh, that's.
But indeed, it gives you modeling-wise several options how to deal with it. One of them, of course, is to figure exactly out how the system behaves. Then you can make it deterministic.
Yes.
You could also use non-determinism to.
Yeah, but here I could try and work with another state, something like that, and say from here. Here it returns. The first time it returns lemonade, and the second time it returns coffee or something like that. Wasn't it like that? I have to think about that. But I know what you mean. I know what you mean. I stop sharing.
A question here then, Machiel. When using this kind of approach, right, and I find myself in this kind of situation, what's the goal that I should be chasing after? Because I would imagine you want to understand what your system does, right? In this case, you've written a spec of how you expect your system to behave. Your tests fail. So normally in my mind, that means that there might be a bug in my system. I have to fix that. But you also just mentioned there's multiple ways you can model that. So what would normally be the goal here? Are you trying to model what the system actually does? Or do you use the platform to identify a bug in your system so you can fix that so that your spec is adhered to?
Yeah. So for now there are actually two ways that you do it. Of course, for this exercise, it's just an exercise to get your hands dirty with AML, so to learn it. But in practice, you often want to continue testing. So you quite often have to model around the bug so that the other interesting stuff you can still test. But for the specific bug that you encounter, you normally would say, encountered the bug, talk with a colleague, hey, I press button lemonade, I get a coffee. And then someone says, hey, oh no, that's not right. But it can, of course, be that you don't know exactly what the system should do. And then you can play around a bit with it. So it can be a way to to do this explorative thing. But I think normally we don't do the explorative that much. I don't know, Theo, do you do it often, the explorative part?
May I add something here? What we normally see, if we have a bug, we find a bug, so something is not according to requirements, then we have found it in one test case, but maybe in the next test case it's much deeper, or in the next test case we will not see it. So what we normally do is we isolate it and we make a model just for this bug, so that we can always replay it, so that in next time that we can have the exact steps to get to this bug. And then, as Machiel said, we normally just want to continue. We don't want to bother the engineers or the requirements engineers for this. And I say, okay, we have seen this one, so we mask that in the model. We say, okay, there's a bug. So this is the thing that we expected, but we have not seen it. We have seen this behavior, and we continue. And sometimes we make also small scenarios there around it to really see what's happening and to analyze it. But that's, of course, we are not there to analyze exactly what the suit is doing, but only to see what we observe and that we can continue. But because sometimes we have a project where we have given the requirements and the SUT, and they ask us, can you check it? And then after testing it, we find 10 or 20 bugs, but we cannot go every time that we find something back to the customer and say, hey, can you fix it, or can you tell something about it? They want to see them all.
I think that makes sense. A follow-on question in that case then is, if you when you attempt to mask a bug, how do you deal with dependencies that and knock-on effects that might have? I can imagine the worst example, say, is that you have a bit of error handling code that effectively is just there to deal with that bug because they weren't aware, right? So how would you deal with something like that? I'm not talking from experience in any way.
Of course not. Purely
No,
hypothetical.
We don't.
But sometimes you mask more than you should there, so that you will not end up in the thing that you would want to see there. That sometimes happens, yeah. But this is something that we did in the past. So 3-4 years ago, the client would also always give us the certain requirements and would test. But now we are much closer to the development teams. So while I'm listening to Machiel, I'm also now testing things, and I'm seeing things that are strange. So I'm sending an email to the developer, hey, this is strange, and he is now going to fix it. So that means the next time. So I don't have to have a bug model. So we already change it on the site, and that's also what the developers will do. So we also have teams that are already using our tools, and they are making the models, and they find things, and they change their model, or they change their system on the test, or the requirements. Even that's happening.
Yeah, or they have it in a CI/CD running, and then they immediately get the feedback. Sorry, Jan, you wanted to ask?
First, I just wanted to brag that all my tests have been passed now because I changed the model in an adequate way. But no, more importantly, would you still say something about your implemented test strategies?
Well, we can. Yeah, we can. So there are several strategies available. The default one tries to optimize on paths. So it tries to cover all the paths as efficiently as possible. But there's also one that you can choose for state coverage, for example. So then it tries to cover all the states. And while testing, there's a constraint solver that we use for the data part. So if there is data involved, it gets a logical formula.
Yeah.
And then
this is where we also use an SMT solver because otherwise you can't make these guard conditions become true. And of course here it's trivial. It's just coverage of a graph in some effective way, but it goes nice and fast. Very good. Yeah. Okay. I have to leave here because I have another obligation. I just wanted to share one idea that we have at our company right now. So
sure.
I was very impressed. It was very nice to use, and I won't say anything about our tool, but something that we have experienced. We have experienced that end users, testing specialists are very bad at writing very complex models. And we are always applying that in the embedded systems world. We are writing models for Airbus as a service, and then we are doing model-based testing with our test engines, and our automated test generation seems to be similar to the ideas that you have inside. And so there are two things that are somehow limiting the success of model-based testing from our perspective. One, complex models are very hard to write. And the other thing is the standards for safety critical systems where our customers work, like railway industry and avionics and automotive industry, they always require an requirements-based approach. So the standards don't say test everything that is in the reference model and then you are done, but the standards say test everything that is in the requirements, then somehow ensure that your code coverage shows that you haven't forgotten anything, and then you are done. So the concept of a model doesn't occur in these standards at all. That might change during the next 10 years, but on the other hand, this requirements-driven approach is not so bad. And at the moment, we are working on an alternative approach. Of course, we won't throw the model-based testing thing away, but we want to offer an alternative, namely that requirements are modeled in a very simple way. So you have a requirement that just needs a very tiny model where things can be left open, so that not every branch is well defined what has to happen there. And then you have a good model for your requirement, which is internally something like a temporal logic formula. And then we create test cases to make an in-depth check of this temporal formula. And we learn a model in the background that is never shown to the user, but this model shows us whether we have tested enough to be sure that this requirement has been appropriately tested. And so it would be model-based testing without writing models, or just with writing very trivial models that are just good enough to say, whenever the temperature is higher than 50 degrees, the reactor is stopped. So that's a very simple model. And then we are exploring this internal formula that we make out of that. And then we are exploring that in every direction so that we can learn a model from that. And if the learning process says this model is now fairly complete, then we can say, if we haven't encountered a bug up to now, we can be sure that this requirement has been appropriately fulfilled. And then, of course, users can get lists of requirements, but our idea is that in the future, customers should not be forced to write complex models for whole applications, like a whole protocol or a whole avionic system function or something like that. And we are working on that. It's very exciting. So that will be the next generation. And of course, the MBT approach will not be thrown away. But at the moment, we have the feeling that if we can get our users to write very simple models, they will have an easier approach to MBT. And then perhaps later on, they write the more complex ones as well. So that's our idea at the moment. And of course, Siemens and Airbus, they have bought licenses of our tool, and automotive industry, some of them use our tool, but we are not that satisfied actually. It should be more. And my feeling is that we don't give enough support to do high quality testing with small models. So that's our next approach. And perhaps
I can imagine it's a bit well, what you see is quite often the systems that they make are complex. So there's intrinsic
Yes.
complexity.
Yes. 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 Exactly.
So the model is also complex. I mean, if the system,
Exactly.
if well, like you see a coffee machine, you can model in even a quirky one in an
Yeah.
hour.
Yeah, yeah, but this full complexity only hits you when you are trying to make a big model for the full functionality. If you're talking about one requirement, the model can be much simpler, but of course it has some undetermined features there. I don't know what happens with when this input occurs or something like that. But we think that with this requirements-oriented modeling, it will be much simpler. Of course, we can't prove that yet, but this is our current strategy at the moment.
Yeah, but I think that's really interesting. I'm just curious how because we also looked into model learning, and we ran into all kinds of problems there. Or well, actually, Jan Tretmans did it for us. That indeed you can have the requirements and the smaller models that focus on a requirement, and then but afterwards, if you want to combine them, then we run into all kinds of problems. So that would be interesting.
Yeah. So exciting times are ahead. Congratulations on your tool. It was very nice to use.
Yeah, thank you.
Let's stay in contact. All the best.
That would be nice. Also
Bye
for
bye.
the requirements part, because we have some solutions. They're also in the safety critical, so that might be interesting to discuss.
Yeah, we might share some ideas with that. All the best, and thanks very much for this presentation. Thank you.
Thank you. Maybe it's good to have a short break for those who want to. Also for those who don't want to. No problem. It's also okay to continue. But just in case you any questions so far? Serious faces.
Lots to think about.
So just for my information, where is everyone? Did some people already get passing test cases? Yeah.
I would like to see the full solution because I know that Jan actually managed to complete the model, but
Well,
I was a little bit busy
claimed,
with my.
but then he escaped.
Yeah, I was a little
like
busy with my newborn son, so I would just want to see a complete model of the lemonade.
I have completed that. I can
are you
share
willing to share?
Yeah, just a quick look.
Yeah.
Because I have a small reflection on the possibilities that how you can solve it, and then we can move on to the for the ones that want to the Internet of Things door.
Okay, so here I have declared 2 more stimuli, button T and lemonade, and also 2 responses. Then I have only one state start, and then I made a choice list, and here I have added actually multiple buttons because in case of lemonade, if you press it like multiple times, sometimes it gives tea and sometimes it gives coffee. So to stimulate that, I added 2 more choices where even if you press button lemonade, it will return tea and also coffee and also sometimes lemonade. So yeah, that's all. And I have ran the tests and so far it's running. Okay. But that is not the same behavior as expected, of course. I mean, every time I am supposed to, if I press lemonade, I'm supposed to get lemonade, but I am not getting lemonade. That's what I understood from the behavioral system.
No, that's a good step.
Yeah.
It's indeed one of the possible solutions that you say, okay, I don't know exactly what I get after I press the button lemonade, because one time I get a lemonade, other time I get a coffee, other time. Did you also already figure out exactly what happens? Why it gives one or the other?
I think this is because of the sequence of the pressing, I think, or the time difference between two patterns, but I am not sure. But that's the behavior I got, but I am not sure why. Probably that could be one of the reasons. Okay, I'll stop sharing.
No, thanks. Thanks for sharing. Thanks for. Does that help, Carol?
Yeah, it did help. Thank you.
And just let me know what is a good moment for you all to where I go through a couple of the potential solutions. I see Adam nodding. You're already looking forward to it.
Given that there's a little bit of a gap, I'm gonna apologize for having to leave now. I have to pick up my daughter. She otherwise will have to crawl home, which is apparently frowned upon in the UK. So we'll not do that.
Oh, how old?
Yeah, it's a weird country. Thank you very much. It was very informative, and I'll touch base with Adam for all the good stuff that's still coming.
Yeah, and I have been invited to give a talk somewhere in May, I think, in Birmingham, Broomies.
Ah, that's not too far from here, relatively speaking.
With Kevin Lano.
Oh, okay,
There's
cool.
apparently some kind of an MDENet thing, so I might be come and bother you.
Ah, very good. Well, just let us know. We'll if you have the time, then also make sure you drop by, and then we'll sort something out.
Okay, cool.
Yeah. Okay.
Nice.
Talk to you later. Thanks, Machiel. Thanks, Theo, as well. Good to see you again.
Yeah.
Talk to you later. Bye.
Bye.
Then I'll start sharing the screen again. So let's go here. So some to look back. So, well, first question to you all. Who already has passing test cases?
Yeah, so it was just about adding a choice to the lemonade state, yes? Just add the coffee and the tea as a choice to be sent.
Yeah, that's one option. Yeah. Adam, did you succeed? You're muted, I think, or not? Could it be?
No.
Ah.
Sorry.
That
yeah,
helps.
No.
Yeah.
So yeah, I got my test cases passing for coffee and tea, and for the lemonade, I went through the different test output and could see that essentially it was giving me back tea or coffee sometimes when the lemonade button was pressed. So I count that as a fault in the system under test. So you'd fix the system under test.
Yeah. True. Yeah, there are faults. And did you also figure out how to model around it?
I didn't try that, honestly.
Okay. No problem. So what I will share now are a couple of ways how to model around it, and to also to show you what actually happens inside the system under test. So this is one possible solution that looks a lot like the one that you show on the screen. It's a bit different. We grouped. So basically, there the solution was to have to move the choice out of the states. So basically, it was a start state, and then have all the different choices. Here we group them. So we said, well, we have coffee behavior. That's here. We have tea behavior. That's there, and we have lemonade behavior, and that's here. And what you see here, it says, well, whenever I am in the state lemonade, the system either sends lemonade, either sends coffee, either sends tea. And this uses the power of non-determinism in the model, because with this you can indeed you get passing test cases, and you also hit all the behavior. And it depends a bit on the system, but it can be that you say, I want to have it more precise. This abstracts from too much detail. Then you can also go one step further. Oh, before that, you can also do it with a repeat. Then what you see then is that the model gets nice and compact. So in this way, basically you could say if you use explicit states, quite often it feels a bit more cumbersome. And also the models get bigger. So if you can make it more compact, that's quite often nice because then it's also easier to read the model. But here you basically see the same thing. The part about the coffee, that's here. The part about the tea, that's there. And the part about the lemonade, it's a bit bigger because it has this choice after it for all the strange, the three things that can happen. And what do you think? Yeah, go ahead.
By the way, let's say I've got like multiple channels. So how do I manage like more complex systems?
If you want to test over multiple channels.
Let's say there's like far more states, and let's say the coffee state is not going back to the start, but it goes to a different mode. Let's say I need to pay for it, and I'm just wondering if it still will look like in this huge blob of code, or I can actually decouple it into some kind of modules.
Yeah, you will see in practice that you start decoupling it. I can give you a couple of examples later on if you like. But in principle, you can also do it like the one on the left, that you have one huge blob. But indeed, what you say, then you run into a model that's hard to read, but also hard to maintain. And there are several options there. So you can put stuff in different files. So that's one way, but you can also put them in different processes or in different what we call behaviors. And behavior is like a bit like a module concept. It's like a sub-process. But let's continue with because there's also another option to model the coffee machine, and that's this one. And I'm interested what you all think about this solution, if that's also a good one. Let's see where did everyone go? You're the only one left, Adam. Oh no, there. Yeah, I see more people. Yeah.
This is a different order of this.
Yeah, it's oh, now I'll already. So basically, what this says is, I either receive a button coffee, a button tea, or a button lemonade, and after that, I accept all outputs.
Yeah, true.
So basically, what in general we think this is too loose, because you could say I use a model like this to explore behavior, but you're not testing very much, because in this case we do see that the button, the coffee behavior and the tea behavior actually works, but it's only the lemonade behavior that's quirky or erroneous. But now you basically accept, well, whatever combination of inputs and outputs the interface allows.
Yeah, so now we just removed those three states for the tea, coffee, and lemonade, and now we're just sending and moving back to the start. Like the self transition.
And here you to give an exact solution, but for that you need to use data. So here, this is a thing I did not explain, but here you declare a variable. The variable is called last, and it's of type string. And by the default value is the empty string. And we have a repeat. We say, well, if we receive button coffee, we send the coffee, and then we update the variable where we say the variable last. We assign the value coffee to it. And for t, we update the variable last with the value, the string t. And then when we enter lemonade, we only send lemonade if we have not seen another output before. So if the last is the empty string. and else we send whatever observation was made in the last, or output was done the last time. And this is the bug in the implementation. So the bug, there's apparently some state that's being kept, and it keeps sending the last output. So this is a way to do this exactly. Does it make sense?
Mm-hmm.
Can I add something here?
Sure.
So we use here a state variable last, but you could also do it without it, but then it gets a little bit more cluttered because you can encode this variable also in the state. But can you go back one slide, Machiel?
Yeah, if they allow me. Yeah, there you go. This one.
So the one that is striked out in red, saying to lose, allowing too much behavior. In this case, we would say yes. If you want to test this system, if you press a button coffee, you want to see coffee, and now you allow everything more or less. But in reality, most of the models that are being used in industry are too loose. So we allow more behavior. Sometimes we do it because we are not interested in the rest of the behavior, just want to see whether all the interfaces are still working. But it's something that we do, and we still find a lot of things there. So although it's here, it's a bit strange, and even already in the smart door, but also in slightly more advanced examples and models, we do things like that, where we allow much more behavior because we are not interested in that part of the system, but in other parts where we want to go into deeper details. And that's all possible with the tool.
Yeah, and I think it's also a good thing to start. For example, if you have already an existing system, but you already want to do some testing, but don't want to or don't have time to model everything, then it's a way of abstraction to already get started with sensible test cases.
I've made a small experiment. So basically, I've added the milk to response. And I didn't add the milk button, but I added it as a choice to be as a response. And I can see, well, for me, it should actually notice me that, hey, there is no milk option. Like there is no scenario that the milk is being received. And I'm just thinking how we can actually detect this like dead parts of the protocol we're communicating with the model.
Yeah, so for that part, we use the coverage. So I can, let's see if if you share your screen, then we can show it.
Yeah, one moment.
Sure. So indeed, yeah, there's no response milk. So you get passing test cases. And so you see there that the that part is not covered indeed, the milk, but you can also visualize it. So if you press on the visualize button there on the on the same screen, bit to the right. And the blue one on top. Yeah, that one. Yeah. So that then visualizes the one on the left visualizes the model. This one will visualize the. But it opens probably in a new tab, right? Because we only see your we still see your covered screen. So there you see the one with the milk, that one is not covered. If you, so if you, no, now you get this is another screen. So I think you now opened the visualized screen. Could it be? Because the one with the coverage, then you see green stuff that's covered is green, and stuff that's not covered is, I actually don't know what to buy. Oh, it's red. Yeah, so there you go. So then you see, but sometimes for bigger models, that's a bit harder to see in one page, but then you see, hey, but this one is not covered at all. And indeed, you already saw, you can also click on it, and then you can go back and forth between the model and then if you click on the thing, then on the right hand side, you will see the part in the model that's where it is.
Also, for bigger systems, it's easier to see. So you have the visualization then divided into behaviors, and the behaviors that are green are all covered, and that are orange are not covered all. And then you can zoom into the behaviors, and there you see the red transitions. So even for bigger system, you can use the visualization there to find it easily.
So I think now is the time to switch to the coffee from the coffee machine to the Internet of Things door. And there we only give you the template in the model, so you have to do everything yourself. But basically the exercise is the same. So this is, but it's just a bit bigger. Oh wait, I get a. Arnab, yeah, no problem. Thanks for joining. And you, it's okay to also do it yourself, Arnab. And then I have questions later next week, or you can also, of course, send them in the email. Then if we will try to reply earlier. So basically for the, let me show you how that works. So in your project, you have to select your smart door. So I have here a huge list, but I select the smart door for participant 70. And then you will see a whole bunch of test sets here. So nine pieces. And the goal of the exercise, all of them, or most of them, have bugs. The Axini one is supposed to be error-free. But basically the workshop is called Bughunt because with the same model, you can test all implementations and find bugs in them. But sometimes you also have to adapt your model a bit to work around the bug or so basically you have to, so we have already provided 9 implementations. There are 9 test sets and they're all connected to a different implementation. And your goal is to write the model, because here you see you only have this process main boilerplate part. So you have to add the interface, add the external interface, well, all the things to get testing, but also of course add the behavior. So as you can read in the specification, it starts in a closed state, but what will then happen if the system gets the open command? What if it gets the closed command? And your goal is to make a model for that. So a bit like the coffee machine, but then this one goes a bit further. And also you don't have to change the model. So it's not that now your goal is to adapt the model to the behavior of the system under test. Well, if you like that, you're more than welcome to do that, of course. But the goal is to find all the bugs in the implementation. So it's a bit more realistic in that sense. And it's also the one that's, we have a couple of courses that all build on the same kind of thing. So we have, for example, a course for to make adapters to communicate with the SUT. Then we also use this smart door model to so we build on top of this model. Any questions about it? All clear so far?
So
Yep.
we should start with the Axini model, yes, first, which is bug-free. And then we can actually check other implementations to see are there any bugs, yes?
Yeah, that makes the most sense. Because then it's also what we do very often in practice, that it's easier if you have a system where you can already model against. Although it's also you run into the potential problem that you model bugs that are actually already in the existing systems without knowing that they are bugs. But yeah, but modeling wise, it's a lot easier because you can adapt and refactor your model. You immediately get feedback if you run it.
So I've started with the partial implementation when I just like two states, opened, or closed and opened. And when I'm receiving the open, I'm going to the open state, and I'm just wondering how to actually. That's a different response. Okay.
Do you need more help or was that already enough? Ah.
Yeah, it's enough.
I was a good rubber duck.
So the starting state, is that always called start, or can you actually specify the starting state, or how does that work? Because I think if I share my screen a second, I was looking at the visualization that it's giving me for what I have, and I get this _1 state. So I kind of made the assumption that that it began in the closed state. Therefore, if I defined closed first, that it would give me that as the starting state. But I assume what I'm seeing here is that, well, that is that is marked as the starting state. So I'm wondering what I'm seeing here with the _1.
Yeah, exactly. Those are the intermediate states,
right?
Or also what we call the nameless states. So those are the ones that, well, in this case, they don't mean very much because there's only one action happening at this _1. Sometimes it's handy to see that if there are multiple actions, that they originate from that state.
Right. Okay. So if I had a choice there, then I'd see more than one thing, I guess.
But in this case, you could also. It's actually we also could have not shown the number.
Right.
But sometimes it's easy to refer to it. For example, if there's either a bug in the system or in the model, then it's nice to know where exactly it happens. So if you now, for example, click on the state on the _1, then on the right hand side, then you see where exactly that state to what line that state corresponds.
Yeah. Okay, that makes sense. That's cool.
And the numbers are also used when you're debugging a test case, when you are exploring. Then this is the place where you are. So we need them
so
to.
if I went to one of my test runs, I should see that in there, I take it?
No, not there. But if you press on the right there, you have this clipboard, and on that the other part is some kind of circle. And if you press that circle, then you get
this one.
Yeah, you get in this case the state vectors, and now you're in main closed, but you could also have been in main _1 or main _3. But there's no.
Yeah, exactly.
You see what you. Yeah.
Okay.
And now there's only one state vector, but often you have 10 or 20 state vectors, and then the difference between state vectors is the local states that you are in the processes.
Yeah. Okay. Thanks.
But the start already looked good.
Great.
Well, how I can actually stimulus the system with the unknown command, because right now I've got the open, close, lock, and unlock, and so I assume that I can just create another stimulus called unknown, and it should respond with the invite command. Yes.
I don't know. Could you share your screen? Then I can have a look with you.
Okay. Sorry, I've got a child entering to my room, so
no problem. It's
not always super responsive. So let's say now it's very simple, but there is a requirement that whenever I receive the unknown command, so I assume that unknown stimulus, I should respond with the invalid command. So I assume that I should do something like stimulus unknown command, yes, and just see that how system responds with the stimulus, yes. That's the idea.
I don't know exactly, because I don't think there's that says a requirement, right? Or let me check how we phrased it. Do you know that by heart, maybe, Theo?
Yeah, I'm just reading it.
Yeah.
There is a when an unknown command is received, the door must respond with the invalid command message. So there's a problem of unknown command, which for me is unknown stimulus. Yes.
Ah,
but
you mean like the dialog 10? Yeah.
Yes, dialog 10 exactly. So it
Sorry,
makes sense.
Go ahead, Theo.
Yes, it makes sense, but we don't have a stimulus unknown command. That will not work.
Yeah. So how to stimulate the unknown command?
Yeah, it's a bit. What we have, we try to be strict here. So the requirements are just requirements of a smart door that exists, and we make a set for that. And the only thing that we support here are the labels that are here. So we have 4 stimuli and a lot of responses. But what you could do is you could try to use one of the responses as a stimulus, because that would not work, and that's an unknown command. But an unknown command is not something that is a stimulus.
Okay. Thank you.
But as a general advice, try to follow the roadmap. So there's a laboratory text there. So we have the specification. So that's one that you have to, in the end, have to do in the model. But there's also the laboratory text, and that's the roadmap how to do it in the easiest way. So to do not, for instance, immediately go into the passcode and try to solve that one, but to just open and close and then gradually add some more to the system.
That's what I'm doing right now. So I'm
okay,
just
very good.
The basic functionality and defining all the states I can actually enter.
Very good.
That's stretching, because when I'm in the closed locked state, I assume that I should not be allowed to request the doors to be opened. So I assume that I should respond with the invite command, yes?
Do you mean if you are in the locked closed state that you should be able to handle an open command?
Yeah, well, I should handle it, but with the invite command, and see, it's not working.
So if you do an open in that state, what then happens?
Yeah, share the screen. Okay, I hope it makes sense. So I'm starting with the state closed locked. And what is the starting state? Yeah, that's the case. How do we know what is this? What is the initial condition of the door?
Mm-hmm.
Because right now I force it to. I'm assuming with this code that the doors are closed and locked, but I don't know what is the actual state of the doors.
It's written somewhere in the requirements, and we start in the state closed and lock. So that's the first state.
So now it should make more sense. Still some errors.
Yeah, but what the labels, the lock and unlock, you have to specify their parameter. So you have to give them data, namely the passcode to lock it or unlock it. And
Okay.
So it's something that I think it's also in the description somewhere.
Yeah, I just need to find the the reference first. Okay, thank you.
Yeah, if it helps, we can also have a quick thing where we show it. Then you have a bit of a feel. But indeed, yeah.
That will be helpful.
Let me find an example where you already see something without giving away the entire solution.
I'm afraid I'm also going to have to drop off now. I've got the opening and closing working and the bad weather part, so I'm going to try the rest a little bit tomorrow and the day after, and then if I hit any blockers, I'll be sure to let you know.
Yeah, no problem.
Right.
And if you, for example, if you just have a bit of a syntax where you run into, just let us know. And otherwise, coming Monday at, what did I say at the beginning? 2 o'clock? I think it was 2 o'clock GMT, right? Wait, I have it on my presentation. There's a
yes, it is.
There's a comeback. Yeah, 2 o'clock GMT. Yeah, 2 p.m.
Great, excellent. Well, thank you very much. It's been really good up to now. And
yeah, did you like it?
Yeah, I really like it. Good.
Nice.
Excellent. Right. I'll have a good rest of your day.
Yeah, you too.
Take care. Bye-bye.
Bye-bye.
And unfortunately, I got a drop off too. It's 5:30, so I have to go out now. I will try it. I'll give it a try again, and I'll try to join the session on Monday 2 GMT. So I think it'll be interesting to discuss more about this there.
Yeah, and if you have any questions in between, just let us know.
Yeah, sure, absolutely. Thank you so much for today's session. Have a great rest of the day.
Yeah.
Bye.
Thanks.
Thanks. Bye-bye.
Okay, so I assume that I need some kind of variable, yes, for the pin. I'm just going step by step through the requirements, and I think the passcode is in the next page.
So let me share a bit what you could, a bit of the boilerplate that you can use.
Yeah, it's just about passing the data, I assume, yes.
So here I have an example where you can, how you can specify the passcode. So you can do something with data. So in this case, what this says is there is an input action lock, a stimulus. The name of the action is called lock, and it has one parameter called passcode of the type integer.
Okay, so when I've got my locked, unlock, I know I need to actually provide this passcode, for example.
Yeah,
But I'm
and
just
for
looking how to
that,
actually,
you need. Let me
how to
check.
pass it.
Wait, let me also get the. That's in the description. So R&D. The lab description.
I can see the reference. There is the param name.
Oh, let me get the right one. Yeah, here I have it. So it's in this part of the specification. So for the, so if you, oh, sorry, it's not the specification, it's the lab text. So it's not the requirements document, but the other document, the one that says, I don't know what do we call it? Oh, just the model-based testing with the Axini platform. And then you go to the part for the smart door. And basically, if you follow this, then you also run into all the things that you have to do. So we try to help you step by step. And indeed, for the locking and unlocking, here you see the description. What I just showed it, that you need a label parameter passcode of type integer. And then to provide a number, you can use the constraints option.
Oh, okay.
With the receive keyword.
Okay, I can see it now.
And you also here see hints, what more you can do.
Okay, got it now.
And of course that part you can then again look at the where's the quick reference here, where you then can look up the parts where it says, hey, here you have to send receive with the constraints option. But there, for example, also is the update option to give a value to a variable. Like what we showed in the where is it? The solution, this solution. Here you see the constraint, but also the update. Yeah, and Carol, I don't know how you're doing time-wise.
Yeah, we need to drop in 5 minutes.
Yeah, no, okay, no problem. Just checking, because in the UK, of course, it's 1 hour earlier, but in the rest of the world, it's not. Because you're also in the Netherlands, right? Because you're with Verum.
No, I'm in Poland.
Right, oh, you're
now.
In Poland, but you
yes,
are with Verum, right, or not? Or
yes.
Yeah,
I'm in Verum.
Nice. Yeah, last time Rutger was also there.
Yeah, I saw the last MDENet webinar, so I was really curious how the Axini works, and I'm pretty impressed.
Yeah, you happy so far?
Yeah. I think I'm a bit lacking this separation between the specifying the channel and the behavior. Like just like everything in the same amount of the code, and I'm just wondering how actually I can decouple them.
Okay. Yeah, so you can put, it's not in this workshop, but you can put stuff in different parts, what we call model parts. So then you can put in one part, for example, your interface declaration and behaviors in different parts. So for example, you could, if you would stretch it a bit, suppose that the smart door was a lot bigger, you could have a model part for the open state, for the closed state, for the just depending on what makes sense for your use case.
Okay, my wife is shouting right now, so I need to go. But is this course will be active for some time, so I can actually come back to it and just...
Yeah, you can. So it's active. Well, at least until Monday, but it can also be longer. But you can just work on your own. So the idea is also that so normally this course takes a bit longer. But we talked with Nuno and MDENet to do it in 3 hours, because for many people 3 hours is already a long time. But for the people that then say, hey, I find this interesting, they can continue. So we leave it open. And on coming Monday at 2 GMT, so that's 3 Central European time, we have a comeback session in which we explain the solution.
Okay, thank you. There is some bigger reference manual for the syntax, I guess. So I probably need to go through it.
So did you receive it or not? Because this
document,
I've
got the small one, the small version, and I was just looking for the bigger version. But I will just look around on the website. I assume that I will find it. Yes.
Well, I don't know exactly what you mean, because the ones that I send around, that's all you need.
Yeah, okay, but if you want to know the backgrounds of it, then you can go to the help page where you...
Yeah, I'm looking for this kind of...
And there you have effective AML, and within effective AML we have a chapter called Introduction, and also a reference manual, and the reference manual is just...
Yeah, I'm looking for the full reference manual, exactly.
Yeah, that's
so
there.
you can find it. You can find it here. So if you go to this, actually, I don't know what it's called.
Yeah,
this academic head on the right. So there is, for example, effective AML, and there you.
Oh yeah. This is it. Okay, I think I need to go through it a bit to understand how the things works. Oh, there's examples. Okay, great. Oh, okay. Okay, I'm happy with that. All right, I need to go right now. I feel that it's really interesting, so I'll try to join on Monday.
Okay, thank you very much, and have a nice evening.
Yeah, have a nice rest of the day. Bye.
Machiel, Theo, thank you very much for the training
thank
session.
You.
This was pretty interesting. I hope I can convert everything by tomorrow into YouTube, and then with your permission, I will share it on our platform and in social media, if you agree.
Yeah, if you have it ready, then just send me the link, then I'll have a look. And if there's, I don't think we made bad jokes, so.
Okay. Sure, we have a deal. So I'll run it by you before I share it with the world. Okay.
Yeah. And sharing with the world, that means on YouTube, or is it for the MDENet only, or?
So usually what we do is we upload it into YouTube so that we can then share it on our platform, on the MDENet community platform, and on social media. If you have any sort of restrictions and you just want it to be shared on the platform, I can have the video as private, and only the people with the link, meaning on the platform, will be able to see it. If you don't have any restrictions, I can have it public, so anyone that goes into our YouTube page and access it on social media will be able to see it.
Yeah, I think that's well. I'll double check it, but I think that that will be fine.
Okay. We have a deal then. Okay. Machiel, Theo, thank you very much. It was a pleasure.
Okay. Bye bye.
Thank you. See you Monday. Bye. Cheers.